the AC power in power vector correction. Okay. All right. Oops. Okay. So first of all, we have to make it clear the remind of the unit. Okay. The unit. So the kilo is 10 to 3 and mega is 10 to 6 and giga the 10 to I'm sorry, that was the 10 to 6, the giga the 10 to 9, milli 10 to minus 3, and micro 10 to minus 6. Okay, and nano the 10 to minus 9. Sometime you're gonna using the pico 10 to minus what? The 12. Okay. All right. So it's very important. All right. So from this chapter, we will learn about the P, the active power, sometime real power. Okay. It depends on the instructor, or it depends on the books or lecture. And Q is reactive power. Okay. The unit is what? Okay, it's very important. And VAR, this is for reactive power. Okay. So, and the last one is S is apparent power. Okay. So the unit is VA. Okay. All right. So from today, for this the chapter, we're gonna learn about the basic concept for PQS. PQS. Okay. So that is for the power triangle. Power triangle. So there was a theta. That was S sub APP, the slope, and that was the P and Q. Okay, so let's say the P is usually that was V sub RMS multiply I sub RMS multiply the cosine theta. Okay, and the Q is V sub RMS multiply I sub RMS multiply the sine theta. Okay, and the last one is S is the two form. The one form is the polar form, that was the amplitude S sub APP and theta, and also that was P plus the JQ. Okay, and so S sub maybe APP was V RMS multiply I sub the RMS. Okay, so we can make a conversion from the polar form to the rectangular form. S sub APP cosine theta plus J S sub APP sine theta. Right? So V sub RMS multiply I sub RMS, the cosine theta, plus J V sub RMS, I sub RMS, sine theta. So here, that was the matching for the previous one. That was the P, the power. That is the Q, reactive power. So this is why that formula is the matching here, okay? Like this one, okay? All right. So go back to the power triangle formula here. So from this one, the trigonometric, we can let's say P square plus Q square is S sub APP square. Okay. So if we wanted to find S sub APP, as we have already know the value P and Q, we can find. All right. And then the apparent to the power from the triangular, the power theta is what? So the theta is equal to tangent d. All right. Any question? So the theta is for apparent power in the polar form. Okay. So the one more things. If the p value is the positive from the triangular, the power tribe may be angular, p is the horizontally to the right. Okay. But negative is horizontally to the left. Okay. Like this one. Okay. Same thing. The Q is for the positive. The Q is the upward. Okay. But the negative is the downward. Okay. Okay, that is very important when you're drawing. All right. So now we have the sample exam. Okay. So S is 800 watts plus J 600 VAR. Okay. That was, we learned before. Go back to the formula that's right there. Here. Okay. The S apparent the power, the polar form, S sub APP, the theta, and then rectangular form, the P plus the JQ. So it means that was P plus JQ. So from here, we can see the P is 800 watts. Q is what? 600 VAR. Okay. So how can we find the polar form of S here? The polar form is what? S sub APP and theta. So S sub APP is what? Is V. Oops, sorry about that. So V sub RMS multiply I sub RMS, or sometimes P square plus Q square. Okay. So, but now from the given the questions, we know what is the P and what is the Q. That's right there. Okay. So 800 square plus 600 square, that was what? 1000. And the tangent, the inverse Q over P, we have learned before. That's right there. Okay. So that was the theta. So the tangent, the inverse Q over P, 600 divided 800 here. So that was theta for 36.9 degrees. So S of S is S of APP. The polar form is what? 1036.9 degree here. Okay. Any question? Okay. So next one. Okay. Oh, I'm sorry. Okay. The second sample questions. Okay. Second sample questions. A system has width of RMS 120 volt and 7 amp. $500 A. Okay, that is the question. All right, I think. Okay, go here. All right. So, DS. Okay. So maybe S is S of APP upon power theta or rectangular form like this one. So S of APP is what? V sub RMS multiply I sub RMS theta. Okay. So from the questions they are given, that was 120 volt multiply 7 amp theta, 840 VA theta. So the okay. Any questions? Okay. So before we find the Q value, the P value was the given, right? This is P, Q, S sub APP. S sub APP 840 VA. The P is 500. So do you remember P square, Q square is like S sub APP square? So Q square, S sub APP square minus P square. Okay. So Q is what? Root S sub APP square minus the P square. So now we know S sub APP 840 square because like there, and minus the P was the given from the question. So just right there. So 500 square. So the Q is for after calculations. And Q is 675 VAR. Okay. So the P we know from the given, and Q we have calculated. So that theta is the tangent, the inverse Q over P. Okay. So the tangent, the inverse, 675, and then the P is 500. And finally, we can get the 53.47 degree here. So the finally 840 VA, and the angle is 53 the point the 47. That is the S. Okay, and then the P plus the JQ for the rectangular form. P is maybe 500, the J 675. Okay, that is the S, the apparent power. Okay. All right. Any questions? All right. So okay, that was let's say, okay, section 3. Section 3. All right. Now we will learn about the power factor. Okay. So what is the power factor? What is the power factor? Okay. Sometime the PF. So the power factor of an alternating the current device or circuit is ratio of the active power P to the apparent the power, the S. Okay. So sorry. So it is the given by the equations. So the power factor is P over S. So by using the power triangular, that was the cosine theta. Okay. I'm sorry, PQ theta. So like this one here, this is the cosine theta. Okay. So, and also the unit is usually the percentage. Okay. So especially in a single phase circuit, the power factor is also measure of the phase angle theta, the between voltage and current. Okay. So next week we're gonna learn more in detail, maybe about the power factor. It's the measure of the phase angle, the voltage and the current. How can they leading or lagging? But usually, the power factor is said to be lagging if the current lag behind the voltage. Okay. While the conversely, the power factor is said to be leading, right? If the current lead the voltage, okay? So the power factor, the lagging means the current, let's say lag, so behind the voltage. The conversely, the power factor leading, the current lead the voltage. Okay. All right. Any questions? Okay. Thank you.